Hey class, Mr. Mohidian here with a trig review video. The thing most everyone remembers about trigonometry is SOHCAHTOA. So if you've forgotten, let's just do a brief refresher. Sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And finally, tangent of an angle is equal to opposite over adjacent. So what does all this mean in the context of a unit circle? Well, it's fairly straightforward. The unit circle deals with the right triangle and the ratios that are created between its opposite side and its adjacent side as the angle gets wider or narrower. So for example, right now I have this theta fixed because this is not a video software that I'm using. It's a whiteboard. But if I were to make the angle larger, so for example, let's pretend the purple is the new triangle. If I make this angle a bit larger, then my triangle would be like this. My hypotenuse is still 1, and yet my adjacent side has shrunken while my opposite side has grown. You see that? It's gotten longer, whereas this has gotten smaller. Conversely, if I had shrunken theta and made it a less wide angle, then this would be my hypotenuse, still 1. My opposite side here would have gotten smaller, whereas my adjacent side here would have gotten longer. So these ratios are fundamentally what the unit circle is talking about. So let's just do a quick breakdown in terms of why, for example, sine of pi over 4 is what it is. So we can memorize this, but it's more valuable to understand what it means. Well, pi over 4, just as a brief refresher, a full circle represents 2 pi of the radius. And since the radius here of a unit circle is 1, the circumference is 2 pi. So half of its circumference would be simply 1 pi, and half of its circumference we, of course, associate with 180 degrees. So a quarter of its circumference would be 90 degrees, or pi over 2, because it's 1/2 of what we're looking at here. And pi over 4 would therefore be half of 90, which is 45. All of which is to say we're dealing with a 45-degree angle. So when you see a question like this, and I know this one's fairly simple, it's asking what is the length of the opposite side when the angle here is pi over 4. So our angle is pi over 4. We know that the hypotenuse of a unit circle triangle is fixed at 1, hence the name unit circle. The question is, because I'm asking about sine, what's the length of the opposite side? Now, because this angle right here is pi over 4, or in our heads we know that as 45 degrees, then we know, because of all triangles having 180 degrees, then this is also, frankly, pi over 4, which means this is an isosceles right triangle, which means we can use the Pythagorean theorem and say a squared plus b squared equals, in this case, 1 squared. But since this is an isosceles triangle, we know that these are actually the same thing. So we can briefly say a squared plus a squared, because they're the same, is equal to 1. And when you solve this, I'll save you the work there, you get a is equal to 1 over the square root of 2, which when you rationalize it becomes the square root of 2 over 2. So a becomes the root of 2 over 2. Well, a represents your opposite side here because of the way we made this problem. And frankly, it also represents your adjacent side because a is also that. So without breaking too much of a sweat, we can calculate that sine, or the opposite side of the angle pi over 4, which is this one right here, is root 2 over 2 because of the Pythagorean theorem and the fact the hypotenuse is 1 and that this is an isosceles triangle. So I went through a lot right there, but that's the basic premise, that sine, cosine, and tangent are asking what are the lengths of the opposite compared to the hypotenuse of 1, the adjacent compared to the hypotenuse of 1, and then for tangent, what's the ratio of these two things together as the angle gets either bigger or smaller. Now notice for a moment that as the angle gets closer to 90 degrees, or pi over 2, you're going to have a very, very tall, skinny triangle like so. So as this angle gets very, very close to 90, or pi over 2, your triangle will look something like this. The hypotenuse is still 1, the opposite side is almost 1, and the adjacent side has now shrunk to very, very small. And the closer you get to pi over 2, the closer and closer, of course, those approach either 1 or 0. Something to ponder there for the future. One other thing I want to mention here, we talked about the Pythagorean theorem in the case of pi over 4. This is also the reason that you arrive at some point in pre-cal that sine squared of theta plus cosine squared of theta is equal to 1. Because, and the reason this is true is sine is referring to the opposite, which we were saying is the x, right? Because, to the y, because if this is the adjacent leg, then that's the x direction, and if this is the opposite leg, then this is the y direction. So I've scribbled all over this thing, but if you go through it slowly and if you pause it, maybe as you go, you'll be able to figure out some of these intermediate steps. Now, even if you've memorized SOHCAHTOA, there's these 3 reciprocal functions which are often forgotten. I've noticed that in class that when you see cosecant or secant or cotangent, some of you are not sure exactly what they mean. So these 3 are simply the fractional reciprocals of the 3 original functions. So cosecant is defined as the reciprocal of sine. So rather than hypotenuse, opposite over hypotenuse, it's hypotenuse over opposite. I'll let you make the jokes yourself there. Secant would be the opposite of cosine. So instead of opposite over adjacent, instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it would be adjacent over opposite. It takes the idea of sine, cosine, and tangent and makes each one of them its reciprocal. So this is something you have to memorize. What's cosecant? It's the opposite of sine. When I say opposite, you got to be careful here. I mean reciprocal. It's not strictly speaking the opposite because inverses will show up in just a moment. So keep that in mind. Now, several times I've mentioned in class that sine, cosine, and tangent refer to waves. And it's very important to realize why that's true. So let's ponder the sine wave for a moment. So I'm going to draw a rudimentary little unit circle here. And below this video, I'm going to have an animated GIF that'll really illustrate this principle much better than I can draw it in this video here. So I encourage you to pause it, look down at that GIF, and it'll make more sense of this. So we start here with the angle measure along the x-axis. So we have a full 2 pi rotation, or 360 degrees. So we're going to start at 0. And remember, sine is the opposite leg of our triangle. Now, if the angle is 0 degrees, then there's no opposite leg at all, is there? This is just a flat line, and there's no opposite to deal with. So the sine of a 0-degree angle would be 0, so we start right there at 0, 0. Well, as I open this up to, let's say, pi over 4, so about a quarter of the way there, then, make this pen a bit smaller, then, well, our hypotenuse, remember, is always 1, but this length has gotten larger. So as my angle got bigger, this got larger. So I'm sort of hitting uphill like this until I get to pi over 2, which of course would be this angle right here, the 90-degree angle. And notice that my y value there, my opposite leg, is exactly 1. So at pi over 2, I get exactly 1. And then after pi over 2, so let me try to mix up my colors here. After pi over 2, my angle is something like this. And notice that my opposite leg here is shrinking. It's getting smaller. It's getting shorter. The further this angle gets larger, the angle the opposite gets smaller. So this is going to start to head downhill. And as I get to exactly pi radians, or 180 degrees, my opposite leg down is back to 0. So we're dealing with this right here. So already you kind of see where this is going. And the cycle simply repeats in the opposite case. Whoops, went too far. And you get this. So this picture here in the corner is a bit of a mess, but again, if you look at the animated GIF below the video, you'll see exactly what I'm talking about. The opposite leg of a right triangle in the unit circle is starting small and then grows until it reaches a maximum of 1 and then shrinks back to 0, and then it goes into the negative region until it gets to -1, and then shrinks until it gets back down to 0 again. So if you watch the y value, the height, you'll see that it grows and shrinks. And that's what the wave does. And then, of course, it repeats, hence the idea of a sine wave. Now, cosine, remember, is the adjacent. So it's the adjacent leg, or the x value. So if you have an angle, right, and as that angle gets larger, the adjacent leg, which is the x value of the right triangle, which in the original case would be this length right here, and in the second case here would be this length here. Notice that the blue is longer than the purple, so it's shrinking. In fact, at our very initial position, before we have any angle measure at all, we have an adjacent or x value length of 1. And then it starts to get smaller and smaller and smaller. So that is why you have this action for your cosine wave. It's the x value's path. And again, if you look at the animation, you'll see that illustrated a bit better than the video does. Okay, so sine wave and cosine wave are the y value length and the x value length graphed as a function of angle measure. Now it's important to recognize what inverse or arc sine and arc cosine and the others are. So remember that the sine of an angle, or cosine or tangent, is a ratio. So this would be an angle measure measured in radians, and this is a ratio, which is a fraction or a decimal depending on how you look at it. Something like opposite over adjacent, which for certain angles is 1/2, or some angles it's √2/2, or whatever. Now, it's important to realize that sometimes you may know what the ratio is, and the question is, what's the angle that creates it? And to do that, we have to invert these values. So to solve for an angle, right, notice that ratio is all by itself, but to get an angle out of the grasp of these sine parentheses are here clasping the sine together, we literally invert these two operations. And to do that, we need to use not sine, but rather the inverse of sine. So if you think back to inverse functions and finding the inverse function, you flip the x and the y, the input and the output. And that's exactly what these arrows here kind of represent. So you take the inverse sine of a ratio, and what it will output is the angle that creates it. So for example, a minute ago, we saw that sine of pi/4 was equal to √2/2. Well, this is equivalent to saying that the inverse sine, and this is another notation for it, of √2/2 is asking the question, what angle measure has this as a ratio? Well, as we can see here, that would be pi/4. Okay, so arc sine, arc cosine, arc tangent, and so on are asking what angle, pi/1, pi/2, pi, 3pi/2, what angle has this number as its sine, cosine, or tangent? Okay? Now let's do a couple of examples. So just like in the last slide, I told you that the inverse sine is asking what angle has, in this case, a sine of 1/2. So there's a couple of ways to look at this. I would look at the sine wave here, which is right here. So this is 2 pi. This is halfway through, so this is just 1 pi. This is pi/2, a max of 1, and 3pi/2, midway in between, which would be a minimum of -1. So the question is, when is this wave equal to 1/2, which would be right through here? Well, a couple of places actually. It looks like 2 places. So the question is, when does that happen? So it looks like it happens right there. So let's try to look at this from the unit circle perspective. Remember, sine is the y value, so the y value needs to be 1/2. So if I have a, for example, 30-degree angle, which is pi/6, 1/6 of 180 is 30. So if that's right there, pi/6, and this is 1, and then this is right here a 60-degree angle, or pi/3, right? So the sine of this angle, this particular one, would be this right here. So it's worth realizing that this is going to be a smaller length than whatever this adjacent leg is. So we're looking for the smaller value just from the geometry of this shape. This is a smaller angle, so this is going to be a smaller side right across from it. So as you remember for the unit circle, there are a couple numbers that keep reappearing. The numbers are √3/2, √2/2, and 1/2. So it's worth understanding what these numbers are in decimal form, because it can help you understand which is the biggest and which is the smallest. So 1/2 is obviously 0.5. √2/2 is about 0.707, and √3/2 is about 0.866. So it's very useful to realize that these are the numerical approximations, or in this case, the equivalent. So I want the smaller side, so which of these numbers is the smaller? Well, remember, this comes only up when you have an isosceles triangle, which this is not. So between this and this, the smaller, of course, would be the 1/2. So this right here would be 1/2, and this would be √3/2. And you can use the Pythagorean theorem to see that this plus squared plus this squared equals 1 squared, or 1. All of which is to say that the opposite here would be the y value, which is 1/2. So what angle, inverse sine, has 1/2 of its ratio as its ratio? That would be an answer of pi/6. Now I was kind of lucky because I started there, but if I had instead started at pi/3, which would be something like this, about 60 degrees, or actually exactly 60 degrees, draw that better, then you see that the opposite leg in this case is longer, right? This is the longer leg, whereas this is the shorter leg of the 30, 60, 90 triangle. So that's why it's wouldn't be right, but pi/6 would be your answer there. Another example, secant of 2pi/3. Now, no one has their secant graph memorized, but what you should know is that this question is really asking, what is 1 over, let's see, secant, the opposite would be cosine of 2pi/3. So if I can find the cosine of 2pi/3, I simply make its reciprocal, and I'll have the answer to this problem. So cosine of 2pi/3, well, a couple ways to look at that again. 2pi/3 would be, let's see, that's pi/2, or half pi. So pi/3 would be, 2pi/3 would be 0.66 pi. So we're looking at an angle in roughly this area, or 2/3 of 180 is, because remember pi is 180, 2/3 of 180 would be 120. So we're dealing with a 120 degree angle, which means its supplement over here would be 60 degrees. So our reference angle is really this triangle right here, where this is 60. So without breaking too much of a sweat, we know that we're dealing with this triangle here. Remember, cosine is the adjacent. So this question is asking, how long is this leg right here? Well, once again, from geometry, you know that this is the shorter of the two legs of this right triangle, because 60 is bigger than 30 is. And this right here is 30, so this is the smaller leg. So you have two options. Is it √3/2, or is it 1/2? Well, 60 is the smaller, oh, sorry, the smaller leg is what I want because it's adjacent, and therefore we know that smaller is 0.5 as opposed to 0.866. So cosine of 2pi/3 is simply 1/2. The reciprocal of 1/2 is 2. And that's how you answer a problem like that. So this is a long video, I'm aware of that, but hopefully you get a better grasp for how to do some trig, and you'll be given a chance to practice on the worksheet. See you tomorrow.